right? As a spin-off to from our notes again, we need now to use those fundamental characteristics of a wave to find properties of any given wave, because we now have the general formulas for on how to get and we know where it is there, like the amplitude, angular velocity, you know how to calculate period, frequency, phase, and time spent. So on exercise on this example 4a, the first part which you need to know is how to calculate. So for this particular example, 4a is given as y equals to 2 sine bracket t plus pi over 3. So we are told, the question says find the following properties of the wave. The properties are amplitude, angular velocity, period, frequency, phase, and time displacement. So the first thing is we use those notes that I gave you. Is we already know what is the amplitude. The amplitude is r. It's that point, the figure which is given there. So that figure is 2. So we know amplitude, which is known as r, is 2, right? That's the first thing. So this, we've already answered the first part of the property. The next is angular velocity. Angular velocity is given as omega, right? Omega is, we know that omega is found there, right? So the coefficient, it's 1 there. We don't write it. Remember, anything which is 1, we don't write. So we know that omega, the angular velocity, is 1 radian per second. Right. The third property, which is the period. The period, which is given as t. We know that the period from the equation, now we use the equation, is 2 pi over omega, right? We already have omega. Omega is in second part, which is given as 1 radian. So which means the number the time taken to complete one cycle is what? Is 2 pi to complete one cycle, one revolution. Because this, so the equation is 2 pi. We now substitute, we know here it's 1, so it's over 1, which is equal to, we remain with 2 pi. So t is what? Equal to 2 pi. So we go back to the equation and see the question and see what next is required. We need the frequency. Remember, the frequency, we already know that the frequency is the reciprocal of the period. So the frequency f is over 1 over t, which is 1. The period is 2 pi. Remember, this is given in hertz, right? You can use your calculator and find the actual value, but I just left it like that because I don't have a calculator here. You use your calculator. This is in hertz. Those are the units for frequency. The fifth property is the phase. The phase, which is given as alpha, right? The phase is this pi over 3. That's what? Pi over 3. Right. Now, the sixth. Now, this phase, as you can see, it's pi over 3, right? So, now we go to the sixth one, which is the time displacement. Time displacement is given as the phase angle or phase over the angular what? Over the angular velocity, which is equal to, remember our angular velocity is 1, so it remains that pi over 3. Now, this is not complete as it is. The time displacement you need to define, is it a lead or a lag? So how you see where there is a lead or a lag, you go to that wave function again. here it tells me that it's positive there. So obviously this one is what? It's a lead. It's a lead because this particular wave function is ahead of this wave when we don't have that phase angle. It is ahead because look, in order for you to get 0 there, here you substitute by what? You substitute by minus pi over 3, which means it starts at minus pi, which is the negative. So it is ahead. It starts before this one starts at 0. If you know how to draw, we are going to show you in the next part 2 how it comes up to that. When you draw it, it will be easier for you to see. So why it is called a lead, right? This time displacement. So this is all on how to get the characteristics of a wave. This particular one is a sine wave, but the way you see it is the same. Remember, look at the notes, you would see that it will be the same thing. The difference obviously is where it starts. Remember, the cosine, it starts at the amplitude, then the sine, it starts at 0. That's the most fundamental thing that you need to know. Thank you.